Friends, thank you for being here today. What if I told you that while the world panics about climate change and argues over carbon emissions, they're completely missing the country that has quietly gained the ability to influence weather patterns across entire continents? And what happens when everyone realizes that controlling rainfall, temperature, and storm systems isn't science fiction anymore, but a strategic capability controlled by one nation that most people think just apologizes and plays hockey? Most people don't know that Canada has become the invisible empire of climate engineering. Our geography controls the jet stream patterns that determine weather across North America. We've developed world-leading technologies in cloud seeding, weather modification, and atmospheric manipulation. Our Arctic territories serve as the control center for global climate oscillations that affect weather patterns worldwide. But here's what should terrify every climate negotiator. We're not just adapting to climate change, we're learning to control it. This isn't just about predicting weather or managing natural disasters. We're talking about the ability to influence precipitation patterns, redirect storm systems, and potentially modify atmospheric conditions that affect agricultural productivity, energy demand, and habitability across vast regions. But here's the question that will reshape environmental geopolitics. What happens when weather becomes a weapon and Canada holds the trigger? This is the story of how geography, technology, and climate science are making Canada the undisputed master of atmospheric control, and why the next environmental breakthrough might come not from reducing emissions, but from engineering the atmosphere itself. Before we examine Canada's climate control capabilities, we need to understand how dramatically weather modification technologies have advanced, and why atmospheric engineering is becoming the most powerful environmental tool available to modern nations. The numbers reveal the staggering scale of weather's economic impact. Extreme weather events cost the global economy over $280 billion annually. Droughts affect agricultural production worth hundreds of billions. Hurricanes, floods, and storms cause infrastructure damage that can exceed the GDP of entire countries. The ability to influence these weather patterns represents unprecedented economic leverage. Weather modification is no longer theoretical science. Cloud seeding operations are conducted in over 50 countries, with programs that can increase precipitation by 10-15% over targeted areas. The technology uses aircraft or ground-based generators to inject particles into clouds, encouraging water droplet formation and precipitation. China operates the world's largest weather modification program, with over 35,000 people involved in cloud seeding operations that cover 5.5 million square kilometers. The program has been used to ensure clear skies for major events, increase precipitation in drought-affected regions, and reduce hail damage to crops. The United Arab Emirates has invested heavily in cloud seeding to increase rainfall in a desert climate. Their program uses specialized aircraft equipped with flares containing salt particles to enhance cloud formation and precipitation. Results have shown significant increases in rainfall over targeted areas, but these programs represent only the beginning of weather modification capabilities. Advanced techniques being developed include atmospheric heating using radio frequency transmissions, ionospheric manipulation to affect weather patterns, and large-scale atmospheric chemistry modification. The High-Frequency Active Auroral Research Program, HAARP, in Alaska demonstrates how radio frequency emissions can heat sections of the ionosphere, potentially affecting atmospheric circulation patterns. While officially for research purposes, the technology demonstrates the potential for large-scale atmospheric manipulation. Geoengineering proposals include solar radiation management techniques that could cool global temperatures by injecting reflective particles into the stratosphere. These techniques could potentially reverse global warming effects, but they also represent unprecedented power over global climate systems. The most significant development is the integration of artificial intelligence with weather prediction and modification systems. AI can analyze vast amounts of atmospheric data to identify optimal intervention points where small modifications could produce large-scale weather changes. This technological evolution is creating new forms of environmental sovereignty and competitive advantage. Countries that can influence weather patterns gain enormous leverage over agricultural productivity, energy systems, and habitability conditions that affect billions of people. Now let's examine what Canada actually possesses in terms of natural climate control and weather modification capabilities. Our advantages go far beyond just having cold winters. We control geographic and atmospheric systems that determine weather patterns across the entire northern hemisphere. Let's start with our control over jet stream patterns, which represent one of nature's most powerful weather control mechanisms. The jet stream is a band of high-altitude winds that flows from west to east across North America, carrying weather systems and determining precipitation patterns across the continent. The Arctic jet stream Its path is significantly influenced by temperature differences between Canada's Arctic territories and more southern regions. Changes in Arctic ice coverage, atmospheric pressure systems, Temperature patterns in northern Canada can shift jet stream positions by hundreds of kilometers, dramatically altering weather patterns across North America. When the jet stream shifts northward, it brings warm, dry conditions to regions that normally receive precipitation. When it shifts southward, it can bring Arctic conditions and severe weather to regions that are normally temperate. Canada's Arctic territories provide natural monitoring and potential intervention points for these massive atmospheric systems. Our position controlling these jet stream influences means that changes in Canadian Arctic conditions affect weather patterns across the United States, Mexico, and parts of Europe. This gives Canada indirect but significant influence over continental weather systems that affect hundreds of millions of people. The Arctic Oscillation represents another climate control mechanism centered in Canadian territory. This atmospheric pattern involves pressure differences between the Arctic and mid-latitudes that affect weather patterns across the northern hemisphere. When the Arctic Oscillation is in positive phase, it tends to keep cold air locked in the Arctic. When it shifts to negative phase, it allows Arctic air masses to flow southward. Research stations in Canada's Arctic territories monitor and study these oscillation patterns, providing data that helps predict seasonal weather patterns across North America and Europe. Understanding and potentially influencing these oscillations could provide unprecedented control over seasonal weather conditions. Our vast boreal forest represents another natural weather modification system. Forests affect local and regional climate through evapotranspiration, albedo effects, and atmospheric chemistry modification. Canada's boreal forest covers over 3 million square kilometers and significantly influences atmospheric moisture, temperature, and circulation patterns. The Great Lakes system, which Canada shares with the United States, creates lake effect weather patterns that affect precipitation and temperature across the Great Lakes region. These massive bodies of water, moderate temperatures, generate significant snowfall, and create atmospheric conditions that affect weather patterns hundreds of kilometers from the lakes themselves. Canadian research institutions have developed world-leading expertise in weather modification technologies. The Weather Modification Association recognizes Canadian researchers and companies as global leaders in cloud seeding, precipitation enhancement, and atmospheric research. Alberta operates one of the most advanced weather modification programs in North America, with cloud seeding operations designed to increase snowpack in the Rocky Mountains and reduce hail damage to agricultural crops. The program has demonstrated consistent success in increasing precipitation and protecting agricultural productivity. British Columbia conducts cloud seeding operations to increase snowpack for hydroelectric generation and water supply management. These programs demonstrate how weather modification can be integrated with resource management and energy production strategies. To understand how this translates into strategic leverage, we need to look at how weather control capabilities could affect international relationships and how climate engineering might reshape global power dynamics. Agricultural productivity represents the most immediate area where weather control provides strategic leverage. Canada already produces enough food to feed on 150 million people, but weather modification could potentially increase agricultural yields while reducing yields in competing regions. Drought mitigation technologies could ensure consistent Canadian agricultural production, while other regions face water shortages and crop failures. Cloud seeding and precipitation enhancement could maintain optimal growing conditions for Canadian crops, while climate change reduces agricultural productivity elsewhere. Conversely, weather modification could theoretically be used to reduce agricultural productivity in competing regions. While international law would prohibit deliberate weather warfare, the capability to influence weather patterns provides bargaining power in agricultural trade negotiations. Energy systems are heavily dependent on weather conditions, creating another area where weather control provides strategic advantages. Hydroelectric generation depends on precipitation and snowpack levels that weather modification could potentially optimize. Wind and solar energy systems could benefit from weather pattern management that maximizes renewable energy generation. Cold weather increases energy demand for heating, while hot weather increases demand for cooling. The ability to moderate temperature extremes could reduce energy consumption and provide economic advantages for Canadian energy companies operating internationally. Storm systems and extreme weather events cause massive economic damage that weather modification technologies could potentially prevent or redirect. Hurricane modification, tornado suppression, and severe weather mitigation could save billions of dollars in economic damage while protecting lives and infrastructure. The insurance industry already pays enormous costs for weather-related damage. Countries that can reduce weather risks gain significant economic advantages through lower insurance costs and reduced infrastructure damage from extreme weather events. Climate refugee flows are projected to increase dramatically as climate change makes some regions uninhabitable. Canada's ability to maintain habitable climate conditions through weather modification could make us the preferred destination for climate refugees, providing demographic and economic advantages. Water resources are becoming increasingly scarce globally. but weather modification technologies could potentially ensure adequate water supplies for Canadian communities and industries, while other regions face water shortages. I want to pause here because this raises a profound ethical question that I'd love to hear your thoughts on. If Canada develops the capability to significantly influence weather patterns, should we use these technologies to maximize Canadian advantages? Or should we consider the global implications and potential responsibilities that come with atmospheric control? This choice could define not just our environmental policies, but our role in global climate governance and our relationships with countries affected by our weather modification activities. What's your perspective on the ethics of weather control? Share your thoughts in the comments below. Beyond immediate weather modification, Canada is positioned to become a leader in large-scale climate engineering projects that could reshape global environmental systems and provide unprecedented influence over climate conditions worldwide. Solar radiation management represents one of the most ambitious geoengineering approaches being researched. This technique involves injecting reflective particles into the stratosphere to reduce the amount of solar radiation reaching Earth's surface, potentially cooling global temperatures and counteracting greenhouse gas warming effects. Canada's northern latitude provides optimal conditions for stratospheric injection programs. Aircraft or balloon-based delivery systems launched from Canadian territory could achieve global atmospheric coverage more efficiently than systems launched from lower latitudes. Canadian research institutions are conducting leading research on stratospheric aerosol injection, studying particle types, distribution methods, and atmospheric effects. This research positions Canada to potentially control future solar radiation management programs that could affect global climate conditions. Carbon dioxide removal techniques represent another area where Canadian natural advantages could provide global climate control capabilities. Direct air capture systems require enormous amounts of energy to extract CO2 from the atmosphere, making Canada's abundant clean electricity a significant advantage. Enhanced weathering techniques involve spreading crushed minerals on land surfaces where they react with atmospheric CO2, permanently removing it from the atmosphere. Canada's vast land area and mining industry provide ideal conditions for large-scale enhanced weathering programs. Ocean fertilization techniques could potentially use nutrients to stimulate phytoplankton growth in ocean areas, increasing CO2 absorption from the atmosphere. Canada's extensive marine territories and oceanographic research capabilities position us to lead ocean-based climate engineering projects. Atmospheric chemistry modification represents the most advanced frontier in climate engineering. Techniques being researched include injecting ozone-depleting substances to create cooling effects, releasing chemicals that enhance cloud formation, and modifying atmospheric chemistry to reduce greenhouse gas concentrations. These techniques require sophisticated understanding of atmospheric chemistry, extensive monitoring capabilities, and international cooperation to avoid unintended consequences. Canadian atmospheric research institutions and government laboratories have developed world-class capabilities in atmospheric science that position us to lead these efforts. Climate modeling and prediction capabilities are essential for any large-scale climate engineering program. Canada's supercomputing facilities and climate research institutions provide the computational power and expertise needed to model complex atmospheric interventions and predict their effects. The integration of artificial intelligence with climate engineering could provide unprecedented precision in atmospheric interventions. AI systems could analyze vast amounts of atmospheric data to identify optimal intervention strategies and monitor the effects of climate engineering programs in real time. However, developing Canada's climate engineering capabilities requires strategic investments in research, infrastructure, and international cooperation that many Canadians don't fully appreciate. Atmospheric research infrastructure needs significant expansion to support advanced climate engineering programs. High-altitude research aircraft, stratospheric balloon systems, and atmospheric monitoring stations require substantial investment and ongoing maintenance. International cooperation frameworks are essential for climate engineering programs that could affect global atmospheric conditions. Canada needs diplomatic strategies that build consensus for climate engineering while protecting our interests in atmospheric control capabilities. Regulatory frameworks for climate engineering don't currently exist, but will need to be developed as these technologies advance. Canada could play a leading role in developing international standards and governance mechanisms for climate engineering activities. Public acceptance and communication strategies are crucial for climate engineering programs that might affect weather conditions across large regions. Canadian communities and international partners need to understand and support climate engineering activities that could affect their local conditions. Environmental monitoring and safety systems are essential for climate engineering programs that could have unintended consequences. Extensive monitoring networks and rapid response capabilities are needed to detect and address any negative effects from atmospheric interventions. Skilled workforce development in atmospheric sciences, climate engineering, and related fields is necessary for Canada to maintain leadership in climate control technologies. Universities, research institutions, and government laboratories need expanded programs in atmospheric engineering and climate modification. If you're finding this analysis of Canada's climate engineering transformation valuable, please take a moment to like this video and subscribe to the channel. It helps us continue producing in-depth analysis of the environmental and technological trends that are reshaping our world. The climate engineering revolution represents one of the most significant but underappreciated developments in environmental technology. Countries that achieve leadership in atmospheric control will influence global climate conditions, agricultural productivity, and habitability patterns for decades to come. Canada possesses natural and technological advantages in climate engineering that are impossible for most other countries to replicate. Our geography provides control over key atmospheric systems. Our research institutions have developed world-class expertise in atmospheric science. Our energy resources can power large-scale climate engineering programs. But possessing these advantages is not the same as leveraging them strategically. Canada needs to make conscious decisions about how to develop our climate engineering capabilities while managing the ethical, environmental, and international implications of atmospheric control. The next decade will be critical for establishing our role in global climate governance. The investments in research, infrastructure, and international cooperation we make now will determine whether Canada becomes a leader in climate engineering or simply provides research and resources for other countries' atmospheric control programs. The choices we make will affect not just our own climate resilience, but our ability to influence global climate conditions and environmental policies. Countries that fall behind in climate engineering capabilities may find themselves vulnerable to atmospheric interventions by others or unable to protect themselves from climate change impacts. Friends, we are living through the emergence of climate engineering as a new domain of international power and environmental control. While the world debates emissions, reductions, and renewable energy, the real transformation may be happening in technologies that can directly control atmospheric conditions and weather patterns. Canada has been positioned by geography and expertise to become the master of atmospheric control. Our territory influences jet streams that determine continental weather. Our research institutions lead in weather modification science. Our energy resources can power climate engineering programs at unprecedented scales. The question is not whether Canada can become a major power in climate engineering. We already have the natural advantages and scientific foundation. The question is whether we'll have the vision and commitment to develop these capabilities responsibly while maximizing the benefits for Canadian interests and global climate stability. The atmosphere is changing, the weather patterns are shifting, and the future of climate control is being determined by countries that can combine geographic advantages with advanced atmospheric science. Canada has the territory to influence global weather systems, the expertise to develop climate engineering technologies, and the opportunity to lead in atmospheric control. What we do with this climate engineering opportunity will determine not just our environmental resilience, but our role in a world where weather control shapes everything, from agricultural productivity to habitability patterns to international power relationships. The climate engineering revolution is here, and it's written in the clouds above Canadian territory. Canada can either master the atmosphere or watch others control the weather that affects our future. Thank you for joining me for this exploration of Canada's climate engineering empire. What aspects of weather control technology do you think offer the most potential benefits? Should we focus on agricultural optimization, disaster prevention, or global climate management? Share your insights below, and I'll see you in the next analysis of the forces shaping our atmospheric future.